Hi everyone, my name's Kavita, and I'm here today to talk to you a little bit about the past, present, and future of detections in security. In an effort to make sure we learn from the past and make the most of the future, I always find it helpful to remind myself how we got here and to take a look at where we started. So, the SIEM space kind of started in the early 1980s, 1990s with the DARPA and the Stanford Research Institute funding a series of intrusion detection technologies that were essentially inference-based. These were known as expert systems. Essentially, these tools had a working memory of facts, user profiles, and risk scores. So they'd say something like, if the login time for a user is outside their normal login hours as determined by their user profile, then let's increase their risk score by 3 points. And then if they come from a host that we've never seen them from before based on the user profile or based on the host profile, then let's increase the risk score by another 2 points. And in aggregate, when we reach some sort of threshold, we fire an alert. These systems were quite sophisticated and actually worked pretty well. They only came to a head when they couldn't keep up with the scale demands of the early 2000s. And as a result, we saw the industry pivot to a more deterministic set of systems, the early SIEMs, the ArcSights, and NetIQs. Now, these rule-based systems were more deterministic, as I mentioned. So if you saw a login outside of normal 9 to 5 hours and you saw a file access and a file download and the file size was greater than X, then you'd fire an alert. And your rule conditions had to be very specific and had to be met in full before the alert would be produced. And the system worked. It solved the scale problem. It was much more efficient and real time than its predecessors. But this notion of behavior or pattern-based alerts that had originated in these expert systems with those user or system profiles was still a very valid form of detection that these early SIEMs were missing. And this need was kind of rediscovered with the advent of the user behavior analytics trend that started in the mid 2010s. And those UBA tools essentially brought back that idea of the user profile and extended it to things like entity profiles and such. They still used batch analytics, which were not very real time, but they were able to fill that gap a little in a way that they were able to detect what's normal and establish baselines and determine deviations from those baselines. Since then, the SIEM space has evolved and expanded even more to include aspects of things like SOAR and XDR, but the hallmarks of detection really still come from the real-time rules and the UBA type behavioral detections. And that's kind of what the modern SOC today wants. Ideally, they'd have these real-time deterministic detections coming from a rule-based system, and they'd have more fluid pattern-based baseline deviation type alerts coming from a UBA type system. All of that without much tuning, ideally, or operational overhead from their detection engineering teams. And this is kind of where Exaforce comes in. So, how do detections work in the Exaforce environment? In Exaforce, it all starts with the data. So Exaforce ingests not just your runtime log data, but actually config data from your various data sources, whether that be cloud or SaaS data sources, and inputs all of that into its semantic data model. Now, this is where we apply meaning and organization to the data itself. That might mean relationships between objects. It might mean permission enrichment or tagging users as admins or not admins. It might mean sessionizing your runtime data, etc. So this is all done in that semantic data model. The data model then feeds into what we call the behavioral model. And this is kind of where the detection piece starts. So these events are all inputted and form a set of baselines. Now, these baselines are pretty numerous and varied. There's baselines for different events, different patterns of events, different users, accounts, orgs, locations, peer groups, times of day, days of week, etc. So a ton of different baselines get built from this data. From those baselines, we get anomalies. Now, these anomalies are then fed into a set of rules. These rules take in not just the anomalies, but the actual semantic data model outputs config information as well. And the output of these rules are what we call signals. So signals are essentially the output of the Exaforce behavioral model. Now let's spend a minute on signals. They're pretty advanced. So you might have a signal that's, say, an ASN anomaly. Now, ASN anomaly is one signal, but it might be able to be detected in different ways. So, for example, I might have an ASN anomaly where a user that typically comes from a cloud ASN is now being seen from a non-cloud ASN. That's a deviation from the baseline, would produce an anomaly and fire this ASN anomaly signal. This is a traditional, uh, in a SIEM, this would be a rule, an anomaly type rule. And that's one baseline deviation in the Exaforce world. But I might also have another baseline that says for this user, I now see them connecting from an ASN from which I've never seen them come before. This is another rule in a traditional SIEM, but an anomaly in the Exaforce environment. And both of these things would yield an ASN anomaly signal. So multiple different baselines can trigger the same signal. The point of doing it this way is that we are essentially able to abstract the details of all the different ways in which this ASN anomaly can be detected from the analyst who's actually tasked with investigating it. Now, you can also have patterns of behavior that are not just behavioral. So maybe I have a set of sensitive actions. If I see a sensitive action performed by someone who's not an admin, that might be a rule. Now, the is admin is not admin information is not coming from a baseline deviation. It's coming from that config data that was the output of the semantic data model. And the list of sensitive actions is actually codified in the rule or in a list. So the signals can be the result of statistical anomalies like the ASN example, but they don't have to be. They can include any combination of config information, anomalies, and data from the rules. So great, we have a signal. What's next? The next step is to take the signal and aggregate it with other signals into what we call detections. We do this aggregation typically based on a session. So a single set of events have multiple different signals. It might be the sensitive action signal, the ASN anomaly, and a location anomaly are all seen on this same set of events. Now, that would yield one detection with multiple different signals. Now, at this point, if the aggregated set of signals does not have sufficient strength, then the detection might not continue down the rest of the pipeline. But a detection that does have a high signal strength will continue down the flow. So let's assume we have a high strength signal, and we're going to continue on to the next step. These detections are now going to undergo yet another set of evaluation in what we call the Exaforce knowledge model. This is where we enrich the detection and its signals with a bunch of other information to really contextualize it and to understand that even though there's this statistical deviation or suspicious behavior based on my rules and anomalies, is it really suspicious or is there some valid justification or explanation from this that we can glean? So we look at information like that config information coming from the semantic data model. This might pertain to the objects or entities involved or impacted. It might also be baseline information that we have from the behavioral model. We look at business context information that SOC team members themselves have provided. We look at historical findings to say, what have things in the past looked like? How have those been evaluated, etc. So all this additional data gets added, and we evaluate the detection and its signals in conjunction with this data and produce what we call a finding. A finding can be true positive, false positive, or benign. And that's kind of the chain of detection creation at Exaforce. So let's talk about why this really matters and why we architected all of this way. First and foremost, the experience that I just described is one that the Exaforce system manages for you. This is a huge deviation from how most SIEMs operate. Though they might ship rules out of the box, they don't traditionally implement the entire detection system and pipeline for you. UBAs, especially, are traditionally very hands-on and require a ton of effort from a very skilled detection engineering team. They can be really cumbersome to manage. And the intersection of UBA type anomaly detections and rules can also be very hard to manage, whether they're managed as independent systems or as things that need to be related. In the X-Force case, this entire pipeline is managed for you. But that doesn't mean that you can't tune it or influence it. You can, of course, build your own rules if you want to. You can influence the outcome of existing rules. You can create exceptions for certain users or objects or accounts that are specific to your organization. You can tune sensitivity of different alerts. You can turn rules on and off completely. And you can include ad hoc business context to influence how detections are evaluated as true positives or false positives. So you have a myriad of different ways to either build your own if you're interested or adjust the rules that already exist. But the entire burden of managing the detection pipeline is not just on the detection engineering team. The next benefit is in the very architecture or staged approach that Exaforce has taken. So the outcome of this multi-stage approach is a really high fidelity, low volume set of detections. So the things that are marked needs investigation really do needs investigation. And that's really down to how the behavioral model was designed, which was that is designed to be forgiving of low fidelity anomalies. So early in the process, we actually generate anomalies for things you would traditionally not even consider putting as a SIEM rule. And we do that because in the SIEM, those rules are of high consequence. An analyst is going to have to spend time evaluating every anomaly that you produce. But in the Exaforce system, there's multiple other stages through which, either via aggregation or evaluation by other models or context enrichment, we can determine that this was actually justified or a false positive and thus not waste the analyst's time. So it's actually okay and even encouraged to have an anomaly or rule that's medium to low fidelity that may often even be a false positive, but maybe once in a while it's not. You can go ahead and include that in the anomaly detection early on in that behavioral model and trust that one or more of the other stages down in the pipeline will filter it out as needed. And so this model kind of allows us to be very expansive with what we capture in the behavioral model and really can whittle down the set of alerts to something that's really high fidelity and low volume. Now, all of this essentially empowers your detection engineering team to use their skills to lead threat hunting activities, to look up new threats or threat vectors, to expand your detection coverage into different parts of the environment that you might not even be covering today. It really allows them to be able to use their skills to go beyond simple rule tuning and optimizing and to actually focus on your true security needs. So this has been a little bit about the past, present, and future of detections. Thanks for tuning in today. To learn more, visit us at exaforce.com.